XII Science, Chapter 7, P Block Elements, Part 4, Trends in Physical Properties. Hello students, I am Madhusina, your chemistry teacher. Let us continue further with the discussion of the physical properties of P block elements. In the previous videos, we have discussed about various physical properties like electronic configuration, atomic size, ionization enthalpy, and electron negativity. Let us continue further with the discussion of two more physical characteristics, that is electron gain enthalpy, also known as electron affinity, and melting point and boiling point. Students, as we already know, as we move from left to right in a period, the atomic size decreases. As a result, if an incoming electron, the nucleus is having strong force of attraction for the outer electron, that is why there is contraction in size. In such a situation, if an electron from outside is coming closer to the atom, the nucleus will try to grab that electron because of decrease in atomic size and strong force of attraction. So in other words, we can say that as we move from left to right, electron gain enthalpy or electron affinity increases. How do we define this electron gain enthalpy? The amount of energy required or released when an electron is attracted by the nucleus, that is called as electron gain enthalpy or electron affinity. So when we are moving from left to right, the electron is readily attracted, so the electron gain enthalpy increases in a period. Now when an electron is readily attracted by the atom, they release energy. So in other words, we can say as we move from left to right, the value of electron gain enthalpy becomes more and more negative because there is release in energy. When we move from top to bottom, atomic size increases. Nucleus is not able to attract its own electrons. In such a situation, if an electron comes from outside, nucleus is not interested in attracting that electron. So what happens to electron gain enthalpy when we move from top to bottom in a period, in a group? In a group, electron gain enthalpy decreases. Decreases means they are showing a smaller value, less amount of energy is given out. In other words, we can say it becomes less and less negative down the group. So, as we move from left to right, electron gain enthalpy increases. And as we move from top to bottom in a group, the electron gain enthalpy decreases. However, we find an exception here in group number 17. The electron gain enthalpy of chlorine is found to be greater than electron gain enthalpy of fluorine. Now this is an exception. Why? When we are moving from top to bottom, electron gain enthalpy should decrease because chlorine is bigger in size as compared to fluorine. But what do we notice? Electron gain enthalpy of chlorine is greater than electron gain enthalpy of fluorine. What is the reason? Due to the smaller size of fluorine, there is inter-electronic repulsion in fluorine. So as a result of that, the electrons, they move away from each other and they are unable to attract the electron. So electron gain enthalpy of fluorine is less than that of chlorine, or we can say electron gain enthalpy of chlorine is greater than electron gain enthalpy of fluorine. Group number 18 shows large positive value of electron gain enthalpy since they are completely filled and have no tendency to accept the electrons. Now the next physical property is melting point and boiling point. If we see all these groups, we find a steady increase in boiling point and melting point as we move from top to bottom in a group. In case of group number 18 shows low melting point and boiling point because they are completely filled, and due to that they show inter-electronic repulsion. As a result, the dispersion force, the weak dispersion force are active between the atoms, and as a result of that, if you see the corresponding period, group number 18 shows low melting and boiling point. However, as we move from top to bottom, the melting point and boiling point increases. Now, let us see the practical trends and compare it with the theoretical trend. We notice that practically as we move from top to bottom, melting point and boiling point increases, but suddenly here there is decrease in the melting point and boiling point. The reason for this is due to inert pair effect shown by these elements.